Hello and welcome to today's lesson where we're going to look at the particle motion in gases, which is part of the particle model of matter topic in GCSE Separate Science physics. So in today's lesson, if we're successful, we're going to look to understand the particle motion in gases. So we should be able to describe the motion of gas particles, describe the temperature and pressure of a gas change with each other, and understand temperature and pressure in terms of the particle model of matter, which forms into the following part of the AQA Separate Science GCSE specification 4.3.1.1, which is the particle motion in gases, and then 4.3.3.2 and 4.3.3.3 pressure in gases and increasing the pressure of a gas, which is only in the Separate Science course of this particular topic. Now, to understand gas pressure, you must be able to describe what the particle model of gases is. So in the particle model of matter, gases can freely move, they can move randomly in all directions, and they can have a variety of speeds. Now, gas particles are freely moving, so have a high kinetic energy store, but they're far apart, so have low forces of attraction, so therefore the gas would have a low potential energy store. So this means that gases have an internal energy made up mostly of kinetic energy and very little potential energy. So to clarify, the molecules of a gas are in constant random motion. The molecules of a gas move in random straight line directions with a variety of speeds. So for this lesson, all we need to do is understand what properties gases have and how we can measure these properties. Now, there are three main properties of a gas which can be measured: the volume, the temperature and the pressure. So to help define and understand these properties, we're going to consider a gas to simply be one particle in a box. Now, obviously, in reality, a gas is billions and billions of particles in a container. But we're just going to consider one. So when we consider placing gas particles in a box, we say it's a closed system. This is because the gas cannot escape this particular box. So gases follow different laws in closed and open systems, but in this course, we only consider gases when they are trapped in a space, in a closed system. So the first property to understand is the volume. Now, this is the space occupied by the particles that make up the gas. In the previous example, it would be the space of the box, and volume is measured in meters cubed. So the volume of a gas is the space between the particles. It is the space that the gas can fill. It isn't the volume of the gas particles themselves, because the volume of a gas is much larger than the volume of the gas particles that make it up. Because as you can see here is the volume of the gas, and here is the volume of the gas particles. Now, because there's lots of empty space between the gas particles, that gives us a volume of gas much larger than the volume of the gas particles. The second property of a gas is the temperature, and temperature is linked to the average kinetic energy of the particle. So it's linked to the speed of the gas particles. So temperature is linked to the average kinetic energy of particles in a gas. The higher the temperature, the faster the gas particles move on average. The lower the temperature, the slower the gas particles move on average. Now, you must state the kinetic energy and speed is an average, as gas motion is random. So this randomness is shown in the fact that we have average speeds and average kinetic energies. Now, work can be done on a gas. This means placing energy into the gas. So an example of placing work into a gas is pumping up a gas in an enclosed volume. Another example will be blowing up a balloon. So work can be done on a gas, which means placing energy into the gas. Now, if energy is being given to the gas particles, then the internal energy of the gas is increasing. But because as most of the internal energy is the kinetic energy store, this means the temperature of the gas increases. Now, the third property of a gas is pressure. Now, when a gas particle collides with the walls of its box or container, it exerts a pressure on that box or container. Now, this pressure is always exerted outwards as the particles collide with the inside of the container. Now, it's better to say that when the particle collides with the container, it exerts a force on the side of the container. Now, this force is at right angles to the container, so this means the force exerted by a gas is always outwards from the container it is in. Now, technically, a force is produced by a gas particle when it collides with the side of the container, because when it does so, it changes momentum. So gases have the following three properties. Property 1, temperature, which is a measure of how fast gas particles move, and it's related to the average kinetic energy of the gas particles. Volume, this is the space in which gas particles move into. And then pressure. This is a measure of the force exerted at right angles to the container or surface when the gas particles collide with the container or the surface. Now there's a law which links these properties in a closed system, which is called Boyle's law. Now Boyle's law considers how pressure and volume are related under constant temperature. Now if the temperature is constant, this means the molecule is travelling at a fixed constant speed because temperature is linked to speed. So if we increase the size of the box, it makes fewer collisions in the same time because it has to travel further with the same speed before it collides with the side. So the bigger the box, the fewer the collisions. So as the particles have to travel further at the same speed to hit the side. So increasing the volume of a gas decreases the pressure of a gas. Now by the inverse of that, if we make the box smaller, the molecule will collide with the box more often since it has a smaller distance to travel with the same speed. So the smaller box, more collisions as the particles have to travel a shorter distance at the same speed to hit the side. So decreasing the volume increases the pressure of a gas, which is important because a high pressure can cause the container to explode or break. So this shows that for a constant temperature, the pressure and volume vary with each other. So as pressure increases, volume decreases. They are inversely proportional to each other. So this is an important idea. Now just to clarify, this can be repeated for any temperature as long as it's kept constant, but the higher the temperature, the steeper the line on the graph. So it's important to note that pressure and volume are inversely proportional to each other. Now this is actually called an isothermal change because throughout this the temperature is staying constant whilst pressure and volume inversely vary with each other. So as a result, you can see that particular idea in this animation. Now we can write this relationship with the following equation. The pressure of a gas times by the volume of a gas equals a constant. Now this is the mathematical way you can express inverse proportion. So if two factors are inversely proportional, then factor 1 times by factor 2 is equal to a constant. Now the constant in this case is just a non-zero value, for example 20, which stays the same for a particular gas throughout an investigation. Now you'll be expected to use this equation to work out a value when one factor changes. Now I actually prefer to write this equation as follows. The pressure of a gas before times by the volume of a gas before is equal to the pressure of the gas afterwards times by the volume of the gas afterwards. Now this can be done because pressure times by volume will give the same constant in an investigation. Now in an examination question, you'll be given 3 out of the 4 variables and be asked to work out the 4th variable. So here's an example question given to you. One of the student's results is given below. The pressure is 2.2 times 10 to the 5 pascals. The volume is 20.0 centimeters cubed. Calculate the volume of the gas when the pressure was 1.5 times 10 to the 5 pascals. So as we know, pressure times pressure before times by volume before equals pressure after times by volume after. So what you firstly do is you write out the equation. You then substitute in the values for the pressure before, the volume before, and the pressure after, whilst obviously leaving the volume unknown. We then make the wanted value the subject in the equation. We then calculate our final answer, and in this case it will be 29.3 centimeters cubed. So in a closed system, a gas has the following laws. The first one is Boyle's law. When the temperature is kept constant, the volume and pressure are inversely proportional. Increasing the volume decreases the pressure as the particles collide less times with the container per second as they have further to travel. This is shown in the equation pressure times by volume equals a constant, where the constant is a number which remains the same for a gas throughout. Now we can also consider the particle model when the volume is kept constant. Now if the volume is kept constant, it means the box has a fixed size, and we can use the particle model to find the relationship between the temperature of a gas and the pressure exerted by a gas, because increasing the temperature increases the average speed of the particles in the gas. So they're moving faster, which gives more collisions, and more collisions increases the pressure of the gas. Now remember, again, it's important to know that a high pressure can cause the container to explode or break. Now moving slower will give less collisions, so less collisions gives less pressure exerted by the gas. So as temperature increases, pressure increases, which is a relationship in direct proportion. Well, this is only one reason why we see this relationship for a gas, because there's actually a second reason. If we increase the pressure at which the particle is moving, not only will it collide with the container side more times, it'll actually hit the side with a greater force. So moving faster gives collisions collisions with a greater force. Now, more forceful collisions give a greater pressure, and remember, a high pressure can cause the container to explode or break. Now, moving slower not only decreases the number of collisions, but it means the collisions have a smaller force when the particles collide with the side. So the less forceful collisions give the lower pressure, so as temperature increases, pressure increases, and as temperature decreases, pressure decreases. It's a direct proportionality. So those are the two reasons why this is observed. So the experimental results for this law are as follows. When pressure and temperature are plotted against each other, we can see direct proportion as it's a straight line through the origin, which we can see in this particular animation. So, in a closed system, the gas has the following law, where the temperature-pressure law. When the volume is kept constant, the temperature and pressure are directly proportional. Increasing the temperature increases the pressure as there are more collisions and more forceful collisions per second. Now, we can also consider what happens to a gas when work is done. So, to do work on a gas means to place energy into the gas. So, the most common way to do this is to pump up a gas. Now, this increases the internal energy of the gas because it will have more energy because energy is being placed into it. Now, as the gas's internal energy is mostly the kinetic energy store, this means the temperature of the gas increases. But as we know, as the temperature increases, the pressure of the gas will increase. So if too much work is done on a gas, the pressure increases so much that it can cause the container to break. This is why a balloon bursts if you blow it up too much. So, doing work on a gas increases the internal energy of the gas and can cause an increase in the temperature of the gas. Increasing the temperature of the gas increases the pressure of the gas. If too much work is done on a gas, the pressure increases so much so it can cause the container to break. This is why a balloon bursts if you blow it up too much. So to summarise what we've learnt in today's lesson, the molecules of a gas are in constant random motion. The temperature of a gas is related to the average kinetic energy of the molecules. Changing the temperature of a gas held at a constant volume changes the pressure exerted by the gas, and you should be able to explain how the motion of the molecules in a gas is related to its temperature and its pressure, and explain the relationship between the temperature of a gas and its pressure at a constant volume. Now, a gas can be compressed or expanded by pressure changes. The pressure change produces a net force at right angles to the wall of the gas container, so you should be able to use a particle model to explain how increasing the volume in which a gas is contained at constant temperature can lead to a decrease in pressure, which gives Boyle's law. Pressure times by volume equals a constant. So you can use this equation to calculate the change in the pressure of a gas or the volume of a gas when either the pressure or volume is increased or decreased. And finally, work is the transfer of energy by a force. Doing work on a gas increases the internal energy of the gas and can cause an increase in the temperature of the gas. And you should be able to explain how, in given situations, like for example a bicycle pump, doing work on enclosed gases can lead to an increase in the temperature of the gas. So if we've been successful and we've learnt in today's lesson, we should be able to describe the motion of gas particles, describe the temperature and pressure of a gas change with each other, and understand temperature and pressure in terms of the particle model. I hope you've enjoyed today's lesson looking at the particle motion in gases, which forms part of the particle model of matter topic in GCSE Separate Science Physics. Thank you very much for listening to this lesson and have a lovely day.